Hello everyone, welcome to another part of diaphragm classes. So in this part we are going to see how you can apply two different diaphragm in ETABS. The first is your rigid diaphragm and second is the semi-rigid, or we can say a flexible diaphragm also. So in the previous part of diaphragm classes we have seen all the theory part, but in this part of the diaphragm classes we are going to apply the diaphragm and we will see that what the results and what all the different things is there in these two of the diaphragms. So let us start. So first of all I will start with the rigid diaphragm. So what you are going to do, you will first of all define the rigid diaphragm. For definition you have to go into define option. In this option you will find a diaphragm option here. So if you look at here, this is the diaphragm option. You will click on this diaphragm. After that, a D1 by default will be named here. You will modify this option here and you will just give it, like if you want to use it as a rigid diaphragm, you just give it RD, which denotes you a rigid diaphragm. You will click on this. You will click on this. So I am using a nomenclature RD to rewrite this as a rigid diaphragm. So when you will be using a semi-rigid, then this will be a CD, semi-diaphragm. It is just a name. Even you can use another name like D1 or D2 also. That's not any problem. So D1 will means rigid diaphragm and D2 will means a semi-rigid diaphragm. Now when the definition has been completed, then you will go to the plan view here and you will go to the select object type and you will select all the floors from here. So you can see here all the floors has been selected here. In the 3D if you see, you will find out that all the floor has been selected. After selecting all the floors, you will go to assign option. In this option you will find a cell option here. In the cell option you will find a diaphragm option here. You will click on this diaphragm option and what definition of the diaphragm you have given in this here will be shown at this position. So suppose that if you have defined more diaphragm here like D1, D2, 3, D4 like that, then all the diaphragm will be coming at this position. So let us apply this diaphragm. So the definition has already had been done in the previous step. Now it's time to assign this diaphragm. So I will apply it. So diaphragm has been assigned in this building. Now again I will repeat this step. First of all, for applying the rigid diaphragm you have to define the diaphragm. For definition you have to go in define option. Here you will find a diaphragm option here. You will modify this and what diaphragm you want to keep it, you will give it here. Suppose that if you want to keep it a rigid diaphragm, then you will give it as a rigid and you will make it OK and make it OK. So diaphragm is defined, but that diaphragm has to be assigned. For assigning purpose you have to go into select object type. First of all you will select all the floors here. So all the floors has been selected. Then what you will do, you will assign this. So again you will go to assign cell. You will find a diaphragm option here. You will select that diaphragm which you have defined already in the previous step. You will apply it. So this is the way of defining the diaphragm and assigning the diaphragm. Now you can run the analysis. Again for running analysis you can go to analyze option and run the analysis from here, or even you can use this play box option as a shortcut for running this analysis. So the analysis has been completed and in this analysis we have applied a diaphragm here. Now let us see the diaphragm result. So you will be going in any of the plan view here. You may come into 6th floor and you will undeform here by clicking this shortcut key, and after that you will go to display option. Here you will find a force stress diagram here. In this you will find a diaphragm forces here. So you will click on this diaphragm forces and now it's come to select the load cases. So as you know that earthquake we have defined it as EQX, which was earthquake in x direction, and we were defined EQY which was earthquake in the y direction. So the two of the load case came here. What you are going to do now, you will select one of the case like EQX. After that you will click on show applied load and you will apply this. So when you will apply this, you will find out that one arrow is indicating here, and this is the arrow where when you will just make the cursor here, you will find that some forces are also showing you. That is a force 593.135. You will just see at this position, you will find out that one forces is showing you when you will move cursor at this arrow position. So again I will make the cursor there. So you can just watch here, it is showing you 593.135 forces and angle 0. What you can do now, you can switch this graphics to the standard mode, then that result which you are looking now, it will be visible more easily. So what you will do, you will close this and you will go to the option here and you will find the graphics mode, and by default or this graphics is DirectX, you will change this to the standard graphics here. So when you will change this to standard graphics and when you will make this cursor, you will find here that it will show you force 593.135 with angle 0 here. So when you will go up, these forces will keep on decreasing. Now it will come to 477 and this will come to the 201. So what is happening now? Software is creating one center of mass here, and in the center of the mass only these forces is applying. So when you define a rigid diaphragm, please remember, when it's very important note I will tell here. When you apply a rigid diaphragm, in that case the forces is applied at the center of mass. So here the center of mass, and here only the forces is applied for every floors. Even you can look at the applied forces with the value. Again you have to go into display option, force stress diagram option, diagram forces, and when you will click show values, in that case it will show you in the value form, like it will arrow will be there but also value will be also written here. So 435 is the forces applied at the 5th floor. So when the it will come into the 6th floor, it is 593, and when it will come to the terrace level, it is 477 here. So when you will match this with the story response plot, the values will be same only. So when you will go into the story response plot option here, and when you will look at the story auto lateral loads to the story, and when you will again select this EQX, when you look at the 6th floor, this values is 593, which is the maximum value. And when you will close this, and you will find that at the 6th floor, this is the same value which is showing you, that is a 593. Also we know that, as I told you, that when you define a rigid diaphragm, there will be a center of mass generated somewhere here for every floor. This center of mass may be at the different position. It is not going to be same for every floor. Might be in the terrace level, or we can say when you will come to another floor, this center of mass position might be going to be changed. Definitely it will go to change only. It's not like it is having a static position for every floor. It is going to be changed for every floors. So it means that there is a creation of one joint here, right? So one joint will be created, and in this joint only the equivalent static forces will be applied when you will define a rigid diaphragm. So no question arises that whether we can directly see that a forces in the joint, because this is a joint, then there is could be a possibility that we can directly, why we cannot see the forces there. So yeah, you can see it. What you can do for seeing that, you can go to the display option, and in this display option you will be finding a load assigns here. In this you will get a joint option here. After that you will select your EQX and you will apply this. Just you can see that same forces is showing you, that is 593, because these forces is applied at the joint that is created by ETABS only. And when you define a rigid diaphragm, and this joint we can call it a center of mass, and for every floor you can just see here this center of mass distance is going to vary, and the value is also which you looking, it is going to be vary, like at the sixth floor it is 593, at terrace level it is 477, because we have applied auto lateral load, and this is the load which is showing, this is the story forces here. And when you will go at top of it at the OST level, it will be 201, and when you will come below, it will keep on decreasing here. At the base it will become a 0 only at the base. So even you can verify this thing from a story response plot also. So you can go to a story response plot and you can just see the auto lateral load here, and when you come at the base, you can find here this base is coming completely a 0 value. Now if you want to see the in-plane stiffness here, you can just go to the display cell stresses forces, and you will select the EQX here, and if you want to apply here, you will find that all these values become 0 here. So if you remember in the previous theory part of diaphragm classes, I told you that if you define a rigid diaphragm, then in that case it will have infinite in-plane stiffness property. So I will write again the word infinite in-plane stiffness properties. Okay, so that's the reason why actually you can just see here, this is the same thing which we are getting here, everything becoming 0 0 0 0 0 0 0 in the cell, because we have defined a rigid diaphragm here. Even if you look at the F22 also, this value will also become 0 only, it is not going to change anything here. Now I will summarize the semi-rigid diaphragm in very simple word. The first thing which I will write in the summary is that a semi-rigid diaphragm, forces will be applied at the center of the mass. So first thing that will be there, force will be applied at the center of the mass. Second important thing that it has infinite in plane stiffness. Third thing you can write, or we can say computation time is very fast as compared to semi-rigid diaphragm. So this is the very important things actually, if you look at now, is there, like forces will be applied at the center of the mass. So I have shown you that how actually it was applying. Second thing is that it has infinite in plane stiffness properties. So this also I have shown you in membrane forces here, when I shown you, like if you go into the cell stresses, and when you click your load cases as EQX, and when you take component F1 or 11 or F22 that is in plane here, and when you will apply this, then everything will become 0, you can see here. So this is the reason why actually it is having a infinite in plane stiffness. That's the reason why you can see everything becoming 0 here. Even this thing you will find in F22 also, so sorry, F11 also. So when you click on F11, so this will also become a 0 0 also only. And if you see the first thing, that forces will be applied at the center of the mass. So for looking this, you will go to the display option, and even you can go directly, you can see from diaphragm forces, or even you can see from the load assigned also. You can select your joint, you can apply it. So you can see here all the forces has been applied at the joint at the center of the mass. So the joint is the same as the center of the mass, and these forces has been applied here. So you can look at that the base is having a 12 point something forces, and when you will come in the OST level, it is having 201, and at the 6th floor it is having a 593. So you can go to the 6th floor, and you can see here this is the value of 593. So same thing you can watch into the diaphragm forces also, you need to apply it. So same thing will be shown here also. So either you can go and see with this option, or even you can see from this option also. These two will give you the same value of the applied forces at the diaphragm. Now in the next part of the diaphragm classes, I will teach you that how you can apply the semi-rigid diaphragm, and there how you can see the different result.